Hi, welcome to Concept Base. I'm John Hepworth, and today we're looking at Year 11 Advanced. We're in the Probability and Data section of the syllabus in the specific section called Probability. And in this section, a lot of the information in here, a lot of the concepts in here, you've most likely covered already, as it does appear in the Stage 5 syllabus in Probability A and Probability B. So if you find that this is an area when you're in class in advanced and you're seeing things that you've seen before, then excellent. It's just a great opportunity for some revision, just making sure you're across those concepts that you learned in the year before. You might find this section a little bit easy. However, if you weren't in, say, an advanced class in year 9 or 10 and you didn't get to see the probability B section, you'll be receiving a whole range of new information in this section. So yeah, you depending on where you're at from last year in year 10, will be depending on where you're at in this topic right now. Where I'm aiming for in this question is I'm looking to extend a little bit those students that did get exposed to this content in stage 5, and want to come at this from very much a conceptual position so you can understand all of the language that's being used in this section, the Venn diagrams that are often used in this section, and the notation, as you can see there for the union notation that is in there. So I'm trying to bring all three together here, and ask a question that asks you to create something. And creating something in mathematics is definitely more challenging than, say, filling something in or extracting information from. When you're actually creating something yourself, it can be a little bit more challenging. So let's have a look at this question. Create a Venn diagram and shade an area that represents A and C or B, given that A and B are the only mutually exclusive sets. All right, so first of all, there's a little bit of language that appears there, that mutually exclusive sets. So we sort of have to define what that means. I think the language probably is a little bit self-explanatory. Mutually, as in the two of them, exclusive. They exclude from each other. The two sets are excluded from each set. There's nothing in the two sets that's a combination of the two. You might have students that like sport and like music, and some like sport and music. So the set of a student liking sport is not mutually exclusive from the set of a student liking music, because some students like sport and music. But in this situation, we're given that A and B, well, it says here, and it's a key word in this question, are the only mutually exclusive sets. So what does that mean? If they're the only ones, then the other sets aren't mutually exclusive. And the other set that is in the question here is set C. So that must mean that A and C are not mutually exclusive, and they certainly couldn't be, because in the question it's asking us to shade a region that defines A and C. Now, A and C would not be able to be shaded if A and C were mutually exclusive, because there'd be no overlap. So what does that look like visually? So if we have a set that is mutually exclusive to another set on a Venn diagram, it looks like that. They just don't overlap. And if we have a set that is not mutually exclusive to another one, it looks like that. It has an overlap. So I won't go into subsets and so forth. You may again have done this in stage 5, but we'll just go for just where this question is at. So we need three sets. We need the set A, the set B, and the set C. But we know A and B are mutually exclusive. So let's draw A and B and have them be mutually exclusive. And now we need set C. Now C is not mutually exclusive to A. I'll label this as A and B. And it's not mutually exclusive to B. So set C is going to include both. Okay. All right, now we want to go and try and make this shaded expression match this expression that we're given here. A and C or B. So you can see the brackets around the A and C section there. So we need to do that first. So where is A and C? Well, that's happening in the union of the two sets where A and C both exist. So on our Venn diagram, that is this section just here, where A and C exist. And then the next part is the other symbol, that U symbol, or, right? So remember, we're remembering and for the N, because it has an N in the word and then the other symbol, the opposite way, is not and so that must be or. So or is adding on to, we're including this plus, or this. So or B. So that means we're including all of B because it says or B. So that even includes this bit that goes a little bit into C because that's all of B. And so there we have a shaded representation of A and C or B, where A and B are the only mutually exclusive sets because A and C are not mutually exclusive and B and C are not mutually exclusive. All right, so hopefully that covers off some language, some definitions, some diagram information, and really clears up the words mutually exclusive for you. Just be aware in your syllabus there is another word that is used for mutually exclusive, and that is disjoint. So if you hear the word disjoint, then that means the exact same thing as mutually exclusive. And again, I think that word is also pretty I don't know, self-explanatory. It's not joined, it's disjoined. Disjoint, so disjoined from each other, not joined. So yeah, that would explain that in that visual representation. As is always the case with all questions, if diagrams aren't given, and you're trying to work something out, I highly recommend drawing pictures. It gives you that checking system against answers that you get. Even in probability, when you come up with some sort of fractional answer, you can have a quick glance over it, possibly a Venn diagram that you drew to represent the information and go, does that make sense? Would that really represent what that probability was? So being good at drawing these Venn diagrams, I think, is an excellent skill set to have to be able to encompass all the concepts of this. And once again, if you are a student that did not do probability A and B, or even just did A but not B in year 9 and 10, I highly recommend doing some questions from a year 10 textbook on that probability, or working through some of the skills-based questions in this area first of all, before you then stretch up into these more conceptual-based questions.